Okay, this is project test 4, video number 2, questions 11 through 20. From a random sample of 50 people, sitting pulse rates and standing pulse rates were measured for each person. That's important. Sitting pulse rates and standing pulse rates were measured for each person. In other words, each person was measured twice. So the fact that each person were measured twice leads me to start thinking that this might be some sort of paired test. May not be, but that's what I want to start thinking about. A coin was flipped to determine whether the sitting or standing pulse rate would be measured first. Let mu sitting represent the mean sitting pulse rate in the population. Mu standing represent the mean standing pulse rate. And mu d represents the mean of the differences between sitting and standing pulse rates in the populations. Which of the following represents the appropriate test and hypothesis to determine if there is a difference in mean pulse rates between sitting and standing in the population? All right, so we know each person was tested twice. And because it's tested twice, whenever possible, you want to be looking at a paired. So that would be telling us we're looking at either D or E. So now we're looking for a key word. And it turns out the key word here is difference. And the fact that they're asking us for a difference, that means our alternative should be a not equal. Now notice this equals 0. When we're working with a paired, 99% of the time it's going to equal 0. It's not 100% of the time, but 99% of the time it's going to be set up as 0, meaning we don't expect there to be a difference. But regardless, the answer to number 11 is D. All right, number 12. Athletes in a particular sport are classified as either offense or defense. So we have two groups, the offense and the defense. The distribution for the weights of the athletes classified as offense is approximately normal and centered around 200 pounds. So they're telling me that we have some sort of center at 200 pounds and ranges from 150 to 250. So basically 50 below, 50 above. Here's my mean. And we have a hump that looks something like this. And this is at 250. This is at 150. The distribution of weights for athletes classified as defense is approximately normal and centered at 300 pounds. So basically the center is up here at 300 pounds. It ranges from 250 to 350. £300, 250 to 350. And we have, well, that's not a very good shape, but there we go. So there's our defense. There are 1,000 athletes in each classification. Which of the following is the best description of the histogram of the weights of the 2,000 athletes? Well, I know I don't have a histogram drawn here, but I can clearly tell that I have two distinct centers. And because I have two distinct centers, and they told me that I did, they told me I had a center at 200, and they told me I had a center at 300. Because I have two distinct centers, this is going to be approximately a binomial distribution, or this is going to be a binomial distribution. Number 13, which of the following pairs of sample size N and population proportion P would produce the greatest standard deviation for the sampling distribution of the sample proportion P hat? Well, first off, what is the standard deviation? Well, it's going to be P hat times Q hat over N, where Q hat equals 1 minus P hat. Now, this is really important for confidence intervals because I usually ask this in terms of margin of error. As N increases, our margin of error and standard error decrease. All right. As N increases, our margin of error and standard error, as this increases, these decrease. But we want to produce the greatest standard deviation, so I want to flip these. So this needs to go up, which means the margin of error is going to go up, and N needs to go down. So I'm going to need the smallest sample size possible, which in this case takes me to 100. And why? As I divide by a larger number, this standard deviation gets smaller. As this number gets larger, as n gets larger, I'm dividing by a larger number, so this gets smaller. The overall value gets smaller. So I want the smallest one of these because as n goes down, my margin of error goes down. I mean, as n goes down, my margin of error goes up, and my standard error also increases. Okay, I want the largest numerator possible. Well, the largest numerator possible we know is 0.5 times 0.5. So as we get closer and closer to 1/2, as p hat gets closer and closer to 1/2, we end up with the largest standard deviation. So this is the one that we want. Okay, so 13 is E. Number 14. A 90% confidence interval for the slope of the regression line is determined to be this. Which of the following statements is true? Now, I'd like you to pay very careful attention to this because this is actually a pretty tricky question. All right, so we know that it's not statistically significant. Why? It contains 0. So it's not statistically significant because it contains 0. Because it contains 0. However, something else we notice is there are more positives than there are negatives. We have more positive values than we have negative values. So consequently, the correlation coefficient of the data is positive, all right? Because we have more positive values, it's weighted more to the positive side than to the negative side. We basically have, oh, our slope is positive, or more likely to be positive, because our slope is somewhere in there. It's like, oh, we have more positive values, therefore our slope is more likely to be positive than it is to be negative. And if the slope is positive, then the correlation coefficient must be positive. On the other hand, had this been a larger negative value, we'd go, hey, there's more negative values, therefore looks like we're more likely to have a negative slope, therefore we're likely to have a negative correlation. But it's just because this is 1.5 is larger than in absolute value terms, is larger than 0.18. All right, moving on, number 15. For which of the following scatter plots is the correlation between X and Y close to the 0? Well, this one is almost a straight line. It's going to be close to -1, and it's negative because it's going down. When I look at C, it's going up and it's close to a straight line, so that's close to +1 because it's going up. This is going down. It's negative, but actually those points are reasonably close to the line, and I can actually tell the direction. So this is not going to be close to 1, but certainly not close to the 0. This is also going to have a positive correlation. And the very fact that I can tell which direction to draw it tells me that even though it's not 1, it's obviously not 0. When I look at this, I'm not really sure whether I should be drawing a horizontal line or a vertical line or a diagonal line. And because I don't know the direction, this is the one that has a correlation that's close to 0. Because I think you can make arguments that it should be a vertical line. I also think you can make arguments that it should be a horizontal line. And by the way, a horizontal line has a correlation of 0, as does a vertical. Okay? All right. Number 16. A matched pairs t-test is not an appropriate way to analyze data consisting of which of the following? Well, if they're going to be paired, if it's going to be a paired t-test, They need to be natural pairs, or they need to be paired together in some way. All right, so let's look at these. Measurement of annual income taken before and after a 2-year training course or random sample. Oh, they tested me before the training course and then afterwards? Because I'm tested twice, paired makes sense. Measurements of annual income for each twin. Oh, we have a twin and we're comparing directly to their twin. Twins make good pairs. Measurement of annual income for both individual and pairs formed by matching 100 people in state A and 100 people from state B based on level of education. Possible. We'll come back to that one. We'll talk about that in a moment. Measurements of annual income for both individuals and pairs formed by assigning 100 people to pairs at random. Here, there is no relationship, none whatsoever. To be a paired test, we need some sort of relationship. Here, it was me. I was tested twice. Here, it was my twin. My twin and I were tested twice. Here, they matched me based on my education level. And since they matched me based on educational level, that is a pair. So that's not going to work either. Here is random assignment. You can't randomly assign me to a pair. So this is not appropriate. And then letter E, measurements of annual income recorded for both spouses. Once again, a spouse is a natural pair, so a paired test would make sense there as well. Number 17, the pulse rate for each person in a sample of 20 men and 20 women. Okay, so we have equal size samples. That's important to note, because if we have 20, because each one of these box plots represent 20, each section represents 25%, and each one had 20 people. So this is 5 people's here, 5 people's here, 5 people are there, and 5 are there. From here to here is 5, then 5. This little bitty section is also 5, and this section right here is 5. So there are more people between the first and third quartiles for women than there are between the first and third quartiles for men. That's false, or 25%. And since we had equal sample sizes, it's the same. The person with the lowest pulse rate is a woman. It's like, no, there's an outlier. We got some outliers here for the men. Lowest pulse rate is a man. At least half of the women had higher pulse rates than 3/4 of the women, than 3/4 of the men. At least half of the women is right here. This right here represents 3/4. And yes, half of the women did have higher pulse rates than 3/4 of the men. So our answer, number 17, is C. Number 18, an airline claims that the mean flight time between city X and city Y is 38 minutes. After taking many flights, a local business believes that claim unrealistic and the actual mean time is greater than 30 minutes. If a group conducts a study to investigate the belief, which of the following hypotheses should be tested? Before I go very far, I noticed that they used X bar. X bar is for samples. We never write our known alternative with samples. That gets rid of A through C. Just because they used X bar, we have to use mu. Has to be. So the initial claim was that the mean was 38. The alternative, well, if the mean equals 38, then we know we're lift mean in 38. The question is which direction? And they said that it is greater. So consequently, we need the greater than symbol. So 18 is E. All right. Number 19, Ali surveyed 200 students at school and recorded the eye color and gender of each student. Of the 80 male students who were surveyed, 60 had brown eyes. If eye color and gender are independent, how many female students surveyed would be expected to have brown eyes? Well, so we have 200 students minus 80 for the males means we have 120 females that were surveyed. So for the males, it was 60 out of the 80, 60 brown eyes out of 80 males. Remember, if they're independent, they must be proportional. Well, in this case, we have 120 females. And we want to know how many brown eyes there are. So 60 times 120 divided by 80, and that should give us 90. 60 times the 120 divided by 80 gives me 90. And sure enough, 19 is D. So 90 brown-eyed females, because once again, remember, they have to be proportional. If they are independent, they are proportional. Number 20. A national health study reported that the proportion of students with elevated blood pressure is 0.15. The principal of a local high school believes that proportion of students in the school with elevated blood pressure is greater than 0.15. So HOP equals 0.15. That's the claim. The alternative, the principal believes it's greater than 0.15. Notice I used a P. P hat is for the sample. We do not use P hats when we write the null and alternative. If a large random sample is used, which of the following is the most appropriate test? Well, how many samples am I taking? I'm only taking one. I'm taking one of the high school and I'm working with a proportion. So proportion, one sample. And by the way, anytime we work with proportions, one sample or two samples, it doesn't matter. Anytime we're working with a proportion, it is a Z. All right, so number 20 is letter A.